right, so you just watched a video about Whift and people who just magically got stronger after drinking, I think club soda, maybe it was. So, well, that is not obviously going to make you stronger. They believed that it did. So, right now, I want you to, in just a minute, pause this video while you talk with your group and work through questions numbers 1, 2, and 3. So go ahead and pause the video and see what you guys can do. Go. Okay, so hopefully you had a chance to talk about questions numbers 1, 2, and 3. The first one is, why do you think that people in the video got stronger? Well, I wrote because they thought the drink would make them stronger, so they believed that they were, and then they tried harder because when you believe you can succeed at something, you tend to try harder at that thing. This is an example of something called the placebo effect, which is definitely a very real thing. People can make their blood pressure go up or down. They can, do lots of different things that you wouldn't think would be easily controlled, but it can be controlled through the placebo effect. People didn't even know that they could do these things. The next question is talking about this little experiment right here that Mrs. Gallus set up. And she said that we're going to measure the initial pulse of people, give each student some caffeine, wait for a little bit of time, measure their pulse rate again, and then compare the final and initial rates. So what are some problems with this experiment that she set up? Here are the problems that I found, and then the solutions are the things that I wrote in teal next to it. So if you don't have these things written down, these would be good things to add to your list. So if you need to pause it here, you can to do that. Now that we hopefully have all of these things written down, the things in purple are the problems. The things in teal are the solutions that I made for them. So the first one is that in Mrs. Gallus's experiment, she didn't have anything to compare the results to. So to solve that problem, I said that we should use a control group. That means that we need a certain group of people that don't drink any caffeine, and then we can see if there's a difference between them. Maybe everybody's heart rate just went up because they were excited to find out if their heart rates would go up. Second thing is other variables could affect the heart rate, such as sugar, carbonation, excitement, just like drinking pop, I don't know, all the different things. So the way that we fix that is we have to figure out a way to control for all of these other variables so that the caffeine is the only thing that's really changing in this situation. And then the last one that I talked about is the placebo effect. People know that they're drinking caffeine, so it really could just be all in their heads. So I said for that, there's this idea of blinding. That's a new word, is blinding. Blinding is when you don't tell people if they're getting caffeine or not. Like you don't, you make your control group and your treatment group, we'll say, and you don't tell which is which. So people don't know if they're getting caffeine or if they're not getting caffeine. And by doing that, it kind of mitigates the placebo effect a little bit. There's also something called double blinding. That's when the person that's interacting with all of the experimental units, the subjects, the people, they also don't know which group is which. So that way they don't accidentally like give it away or hint at anything or tip people off at all. So the next one says to design an experiment to test the effect that caffeine has on heart rate. So why don't you guys pause this video, take a couple minutes, and see if you can do that. If you need an example to look at, you can look at yesterday's example that we did about the SAT prep class on the previous page. So go ahead and do that now. Okay, so the first thing you have to do is you have to talk about how you're going to randomly assign people. So I said that you had to first label all the experimental units, and I just said 1 to 32. Then use a random number generator to choose 16 unique numbers. Remember, all the underlined things are words that you kind of have to use. So label, random number generator, or some other randomization. Unique is important. Then you're going to select the corresponding students and give them Coke, and then give the remaining students the caffeine-free Coke. It's important that we use Coke and caffeine-free Coke because this allows us to control for all other variables. These are the same in every other way. They have the same amount of sugar, the same chemical makeup, same carbonation. Everything is the same, except one has caffeine and one does not have caffeine. So this controls for all the other variables. And then we're going to talk about, or we're going to show the diagram of how our experiment is going to be set up. So we start with 32 students. These are the experimental units. We do random assignment, which we talked about up here already. We group them into two groups with 16 in each group. And then these are roughly equivalent groups because we use random assignment. So that means that in theory, these groups should probably have about the same number of like boys and girls, athletes and non-athletes, people that respond to caffeine and people that don't really respond to caffeine. All these different variables that could be messing with our experiment, they could be confounding. We're going to kind of like balance them out by just randomly putting people in groups. And then one group gets the caffeine, one group doesn't get the caffeine, and then you compare the change in heart rate. So on the back of this paper is all of the important things that you should write down. So in just a minute, go ahead and pause this video, take some time to write all these things down. Then we're just going to kind of talk about a couple of them really quickly. So go ahead and pause the video now. Okay, so now that you've had a chance to write all these things down, I do want to talk about this part right here, the 4 key principles of experiments. In order to be a well-designed experiment, you should have these 4 things. The first one is comparison, which means 2 or more treatments. You have to at least have like a treatment and a control group because you need to be able to compare the results at the end, and you can't compare results if there's only one group. So you have to have at least 2 treatments so that you can compare. The second thing you need for a well-designed experiment is random assignment. This makes it so that all of your groups are, in theory, roughly equivalent. So that helps control for any other confounding variables, which leads us to the third thing you need for a well-designed experiment. You need to control all the other variables. You need to make sure that everything else is the same in the experiment except the one thing that you're trying to test for. And then the last one is called replication. That means that you have group sizes that are big enough to clearly distinguish a difference. For example, if you have, the caffeine and the non-caffeine, and you have like 2 friends and you give one person caffeine and one person not caffeine, that's not enough to really tell us anything because there's only one person in each group. You have to be able to see the results replicated throughout many people in each group, which means you have to have many people in each group. So replication really just means you need big enough groups to clearly and consistently see the results that you're noticing. So now go ahead and try to check your understanding with your group. So pause the video and take some time to do that. Okay, so the first one here says to explain why it is important to have a control group that didn't get a mark on their rear. And the importance is that a control group provides baseline data, so we have something to compare to, because comparing is an important part of a well-designed experiment. It's one of the 4 key principles. So we need a control group so we have something to compare it to. It shows how many deaths that there are with no treatment, like the baseline. And then it says, suppose there are 1,200 cows, describe how to randomly assign them into treatments. So again, label the cows from 1 to 1,200. Use an RNG to select 400 unique cows. Make sure you have these underlined words. Assign the corresponding cows to get eyes. Then repeat the process to select 400 more cows to get crosses. And then the remaining 400 cows get no marks at all. And the purpose of this random assignment is so that we can create roughly equivalent groups, because we're balancing out, in theory, we're balancing out all the other variables like size of the cows, color of the cows, etc. And then here is my diagram. So we start with 1,200 cows. We use random assignment, which we talked about up there in part B. We split them into 3 groups with 400 in each group. And then we say which treatment each group gets, I's, crosses, no marks. And then we compare the number of deaths. So that is 4.2 part 2. Now, if there's any time left in class, go ahead and work on the textbook assignment for 4.2 part 2, or any of the textbook assignments that you haven't done yet.